developing a new solar vernacular for New Mexico, and I would like to show you why. I'm somewhat of a pirate in this whole green building movement, and don't necessarily go with the norms or believe what I'm being told. I cut my teeth about 1975 at the Ghost Ranch Conference Center, where I worked with the Sun Dwelling team, a wonderful group of solar pioneers from New Mexico. Many of them were the founders of the New Mexico Solar Energy Association and have been designing passive solar adobe homes since 1935. Some of the great people have been Peter Van Dresser, William Lumpkins, David Wright, architect, Francis Westling, and the late great Buck Rogers, engineer. It was an incredible experience to work with them. I was the young architectural gopher on the team. After we finished the project, can we turn the lights down so the slides come up a little brighter? Is that possible? I stayed on at the ranch teaching 1 month college intensive programs on renewable energy. I'm fortunate to be able to work with people like Bristol Stickney here in developing guidelines and potentials for the state of New Mexico on integrating the technology of night sky radiant cooling. I've been published in many books, magazines, and museum displays. This is a Department of Energy publication, Building for Sustainable Case Studies, and I was fortunate to be on the cover, as well as the inside cover was really nice, a nice big picture of this house and a nice article on the building. The building was also published in Solar Today magazine. This was the first time I got an architectural cover and felt pretty good about it. I've gone on to get other covers and other articles from Solar Today, the official magazine of the American Solar Energy Association. In 2012, I was awarded the Passive Solar Pioneer Award from the American Solar Energy Association, so some people think I know what I'm talking about. I'm also a member, an active member of the New Mexico Solar Energy Association. But here is my presentation. A lot of people are used to seeing all kinds of pretty pictures. Well, I left those out this time, and I'm just going to talk numbers, because I think it's really important for people to understand how passive solar works and the potentials of passive solar. So let's start with a piece of glass, 1 square foot of glass, and what are its characteristics. You have various values that you will get from the glass manufacturer, giving you the characteristics of the glass, the U value, which is the insulating value of the glass, and then your solar heat gain coefficient, which is the amount of energy that comes through the glass as a percent of the energy that strikes the glass. So with this, I'm going to be answering the question, what kind of glass do I use for my house? I get this all the time. I'm sure a lot of you get that. And it's not a quick answer where you could just say, use this. You need to know the function of the glass, the orientation of that glass, and what you want that glass to do. So you have to do what we call an energy balance. And part of that is comparing the gain that you get from the glass to the loss that you get through the glass. And on a 24-hour period, we used a very simple number. Here it is. Yeah. Area times U, which is the insulating value, times the delta T, times 24 hours will give you the heat loss in a day in BTUs. Okay? So we are using for a delta T a number of 40, because I'm starting with the January average temperature. The average January temperature in Santa Fe is 30 degrees. We want to keep the house at 70 degrees, so you take 70 minus 30, and you come up with a 40-degree delta T. Standard Ashrae heat loss calculations. So for 1 square foot of glass, understanding the loss and understanding the U value of the glass, different characteristics or different types of glass will have different characteristics or different loss. And this is the loss off of single glazing, double clear over clear, and 2 different types of low E. the 180 and the 366. Now, we also have gain on that glass, okay? We looked at the loss, different losses. We also have different gains, which play into the percent possible sunshine, because we have clear day solar energy, okay? This is in a perfect world on a clear January day. This is the amount of energy that is going to strike that glass on a clear January day. So different orientations, south, north, east, and west, you have different gains. And look at the gains that you get in January. But that's not what's coming in through the house. You have to degrade that number because it's not a perfect sunny day every day in January. So if you want to look at a January average, you've got to look at the average amount of gain that you get on that surface. So it degrades from 2,000 down to about 1,400, and again will drop with various types of glass or different orientations. So we now take 2188, drop it down to 1408, and then we have to run it through the solar heat gain coefficient number to find out how much energy you actually get down into the space. So the gain has been degraded, as you see. Now we're down to 1,200. BTU's gain coming through the glass. We looked at the loss, losing 998 BTUs, so you end up with a plus here of 212 BTUs. 40 years ago, that looked pretty good to us, you know, because everybody had single glazing. Then we came out with double glazing, and we got all excited. Look at that. 3 times as much energy almost that we're able to harvest through double glazing. And if you take that down to low E, there are different types of low E. Low E is not always the same. Look at the difference in gain that you will get from 188 to 380. And if you look at the losses, you have more losses here than you do here. I mean, more losses here than you do here. But if you look at the net difference, this low E looks a lot better than this low E. In fact, this low E has less net gain than single glazing. So when somebody says, use low E on your south wall, your response is, what kind of low E? There's a big difference. Also look at, you know, your east and west sides. They don't gain as much, your north. And again, this is just January average. Let's look at June, because that plays into it too. What you might gain in the summer, I mean in the winter, you might lose in the summertime because the house gets too hot. So again, you have various gains and you have various losses depending on the characteristics of the glass and the orientation that that glass is facing. So when you do the net balance, you can see that you may have a little bit of a problem here with the 180 if you have it on your east and west orientations. So you may want to go to a different low E for those orientations, or even just save yourself a little money and go up to the clear over clear. So that might help you answer, what kind of window do I want on my home? Okay, now we're going to take that and we're going to expand this numbers game to a little house that I just finished designing and having built up in the Abiquiu area. It's for a single woman. It's 1,500 square feet, 3-bedroom house. It's a really sweet little thing. Fair amount of trom walls with selective surface, integrated with direct gain windows, and the hallway connecting all the rooms is kind of expanded from a 3-foot hallway to a 8-foot hallway, so it becomes more of a garden room transition for all the spaces, and indirect way to harvest the energy. So this is the house under construction. And now let's start cranking some numbers on it. This is my basic Ashrae heat loss, heat gain calculations. This is not what I would use if I was actually engineering a passive solar home. I'd go to more sophisticated programs, but I did this because it's very simple to show you the energy balance of the home. So what we did is, again, we used that same formula, area times your U times your delta T, I missed a little X there, times 24 hours is your heat loss for the day. Again, using a 40-degree delta T. Here's my areas, my U values, my delta T's, my hours, boom, total it up. There's my steady state heat loss in BTUs for a 24-hour period. That's not all the loss. That's just your conductive losses through the skins of the building. We also have an infiltration loss, which is the amount of energy you lose through cracks around your doors and windows, air moving across the house. You lose greatly. We're now building houses where we're getting numbers down to about a half an air exchange per hour. When Bristol and I first started cranking numbers like that, we'd fight whether it's 3 air exchanges per hour, or maybe if we built the house good, we'd call it 2 air exchanges per hour. But it was a big guess number and always, debatable. But you come up with a number, and then you add your steady state to your infiltration losses, and you come up with a total heat loss of the home. And if you see that, we're over 274,000 BTUs on a day. You can convert that by dividing it by 3,414 BTUs per kilowatt times 13 cents a kilowatt, and it'll give you about, I think it was $8 to $11 per day in there. No, I'll take that back. The difference will be that. I'll just keep those numbers in mind. So we have this loss of 275. So let's go ahead and take our orientations of our solar glass, 275 square feet of glass on the south, times the BTU gains that we get on an average January day through multiplying your clear day through your percent possible sunshine times your solar heat gain coefficient. We degrade down to these numbers in BTUs per day, but you multiply it out and you get a certain amount of gain, total gain, for the house coming through your glass. So if you balance your glass gain to your loss, you end up with, in this design, a net plus of about 25,000 BTUs, which comes up to about 109% of the loss is covered by the gain. So this is a pretty good passive solar home. And it's just basically kind of showing us the potentials that we can get through passive solar gain. Okay, so let's take the same house and bring it down. See, I had insulating values that I use in my designs. And now we are under the new International Energy Conservation Code 2009, which has been accepted by the state of New Mexico construction industries as a standard you need to comply with to get a building permit to build your home. They want to make sure that your home is energy efficient enough. So I said, okay, let's degrade my design down to the standards of the International Energy Code, and I come up with a loss now we're at 345,000, about 100,000 BTUs more in loss, same amount of gain because I used the same glass, and we end up with a net loss of about 47,000 BTUs on an average January day. So going by the standards of the code, we didn't quite come up to 100%. We ended up with about 86% of the load being met by passive solar. Still not bad, acceptable. I don't think anybody would complain living in a house like that. But let's start playing games. Let's take this same house and turn it 180 degrees so the 275 square feet of glass is now facing the north. And we have various gains coming in. We have 28 square feet now. Instead of the north, it's to the south, and 275 square feet of south is now to the north. We come up with a gain of about 88,000 BTUs compared to our loss that we had to code of 345. We end up 257,000 BTUs short of meeting our goal for a passive solar home on an average January day. So with all the glass around the house, we're taking in about 26% of the loss in solar gain. I also wanted to take a look at June, and as I said, you know, you got to watch your glass in the summertime, because what you gain in the winter you might lose in the summer. And I said, okay, let's turn this house so the 275 faces east. And I don't know if you remember my chart. If you do, you better than I. But when you look at percent of possible sunshine, you have more gain on the east than you will on the west. These numbers here. And why is that? Because usually we have storms and stuff like that more in the afternoons than we do in the mornings in June. So you have more gain on the east than you would on the west. That's these two numbers here. So watch your east as much as you watch that western sun. Okay, now that yeah, Lloyd.
When you were reorienting that building, were you taking into account the different E values on those glasses? Like when you turned that glass to the north, did you use it like a different E value?
I'm trying to go back here now, and I'll show you. How did I go back here on this? This one? Slide. Oh, previous. Okay.
Go to slide.
Previous. Well, there was one right there. Previous.
That one?
Well, it doesn't. Yeah, go back to. Lloyd had the question. Back again. There's that previous, that second thing. Yeah. There we go. All right, Lloyd. It's okay.
You're reorienting the building. I mean, now when you're putting that glass on the north, are you using better E values than you would have had they been on the south?
No, I'm just using the code approved glass. This is what we want you to use. So I just plug that in, and we come up real short when we go to the north. So you can see the difference in orientations of this home with this methodology. Now we want to go get a building permit. We need to comply with the International Energy Conservation Code 2009. Unless you get this to pass, you will not get a building permit. And I have used this program. It's called ResCheck. You can get it on the web for free, and you can fill it out and see if your house complies. And if it complies, you can go out and get your building permit. So this is the first run I did with the ResCheck. I put in my areas, and I put in my insulating values, and I come up with an overall AU number. There it is up there, my AU number, and area times the U value. It's a big average for the house, and that's the number they work with. And look at that. I passed by 19.1% better than code. Very nice. I'm very proud. So that's it as we built it. Now, let's take this same building and start playing numbers. Okay? They have this thing called orientation. Building faces 0 degrees from north. And what do they mean by faces? Well, they say pick a front of the house, you give it an orientation, and then everything works off of that. So instead of giving you east and west and north, it's front, right side, back, left side. But at some point, you got to tell the front of the house faces north or south or whatever. So I took my wonderful passive solar home, and I turned it 180 degrees so that 275 square feet faces north. And I said, what's my compliance? Look at that. I passed by 19.1%, the same number. Go build it. It's equal according to the codes. So I kind of took a little offense to that. Said, okay, let's play the game. Let's turn the building as built back to the south. but take out all that 275 square feet of glass, okay? And just do it as a normal house and just put in 40 square feet of glass. Get rid of all this passive solar stuff and run your calculations again. What happens? 19.7% better. We get better by taking out the passive solar. I'm sorry, I'm offended.
So you're saying that's wrong, right? You're saying those
Of
numbers
course
are wrong.
that's. It's only looking at half the picture. It's only looking at the loss. It's not balancing it to the gain. So in their eyes, these houses are equal. Go out and build it. So, you know, I'm a little perturbed about that. And then I went ahead and I brought this house down to their code, down to their standards, not my standards, their standards. Run the calculation. This is facing south now. Run the calculation, great. 3.1% better than code. Just passed. Okay, take the same thing and turn the building 180 degrees so all the 275 square feet of glass faces north. And I said, I'm going to get clobbered. 3.1% better than code. Same number. Okay, so if we extrapolate the information that I've shown you, I can take out a little bit of the ceiling insulation in the house I had before and get it to where it did not pass. A nice, beautiful passive solar home, all this glass facing south. If I take a little bit of the insulation out of the ceiling, I'll get a number and it'll come up maybe 2% less than code. What do? Simple, take out all the solar glass. Your number will go up, you pass, you can get a building permit. This is 2014. I started doing this in 1974. And it's about time they start understanding what was known here 1,000 years ago. And understand that we don't have to build to these crazy codes, and we need to start using common sense. I needed to put this kind of slide in because this was last Sunday, our Easter hike. And it was just very, very nice to be there. This is Pueblo Bonito out in Chaco Canyon, one of the most inspiring passive solar buildings in all of New Mexico. But the new codes, this is what we're getting. This is your award-winning, sustainable green home in Santa Fe. This is the new solar vernacular for Santa Fe, not this. This stuff supposedly doesn't work very well. But 1974, I remember David Wright, architect, sitting with myself, Peter Van Dresser, and Bill Lumpkins, and said, we are on the verge of developing a new solar vernacular for New Mexico and the world. And sadly, we're still waiting for it to happen. This is less than a mile from here. And this is a green, sustainable home, not this. This is getting to be a dinosaur. You know, I've been bawled out by the U.S. Green Building Council and the New Mexico Green Building Council as being, what did they call me, an old mossback for not understanding, you know, thermal bypass and, you know, all that other crap. And now instead of building homes for people, we're building them for automobiles and calling them green. And this is the vernacular that I had hoped we'd develop here in New Mexico. But this is it. You know, this makes no sense, but to the codes, it is just fine. In fact, you get extra credit for putting all those PV panels up on your roof. So that's my presentation, short and sweet. So any questions, I'll entertain, yes.
It's interesting that the speaker from Positive Energy was saying how there was no tax deductions for windows. And you can show clearly that, you know, you're saving on heating costs, so there should be tax deductions on windows.
It depends on how you show it. You know, there's no tax incentives or credits for utilizing passive solar. Why? You don't need them. It's economically feasible without it. You know, but everybody says, oh man, if I put these things on my house, the government's going to pay 40%. That's great, and I'm going to get a check every month. They don't realize they're just getting their own money back. You know, I'm not putting it down, but it's not necessarily the first thing you do. And you don't consider yourself a solar home with your garage to the south and PV panels on the roof. That makes no sense to me. We need to start understanding the resources that we have available to us and start developing regional standards and build to that. We'd be much better off. You know, you see, I'm not afraid of using panels. Yes?
Are you getting active resistance to that? Or is it just active kind of?
Well, it's been totally ignored, and it's still ignored. You know, and all these new codes don't necessarily take into account passive solar gain and passive energy. You know, I really went up against the U.S. Green Building Council with the LEED program when it first came out. Because I said, well, what about passive solar? There's no way to put a trom wall in, let alone a trom wall with selective surface, into your programs. There's no way to integrate thermal mass into your programs. And with that, how can you tell us you're analyzing and incorporating passive solar gain? It makes no sense, and it does not work, and it'll never work. So they need to change the codes to start respecting these things. You know, now in the city of Santa Fe, you want to sell a green home, you got to post this big sign on your building saying, my HERS rating is 65, or my HERS rating is 33. That means nothing to anybody. Why don't we have a sign that says your free passive solar contribution is? And once we start getting that, people will start integrating these technologies.
Sounds like you need to show them the dollar savings or how much they would be spending on their utilities versus.
Who's they? Who's they?
Buying the house.
Well, you know, everybody that comes to me knows.
Mark, can you repeat people's questions?
Oh, I'm sorry. Okay, next time. Any other questions? Yes, Steve?
Mark, have you done the same calculations using REM rate program to see if you get the same result?
No, I haven't. I haven't bothered with REM rate in quite a while. It's definitely more sophisticated than this, and it may integrate some of the passive solar better, but unless you do an hour-by-hour simulation, you really cannot understand the potentials of passive solar. Because, you know, you can overglaze a house, and with my calculations, it looks super fine, but the house will not work because you'll fry. So it needs to understand the mass, what is stored, needs to understand the temperature the house starts from in the beginning of the day, what happens during the day. You know, there's so many programs that go through hour-by-hour simulations, and that's the way to do it.
It'd be interesting to see what the results would be compared to ResCheck between the
It may be more sophisticated, it may not show up like this, but the average person, the average building, is not going to go through REM rate. You know, they're not going to do that unless they're going for the sustainable building tax credits here in New Mexico, correct? And those things are not worth doing unless you're building a big monster house anyway. If you're doing a small, rational house that's, you know, 1,500 to 2,000 square feet, you're not going to get enough money back from the government to justify all the paperwork and hoops and tests and third-party people you need to bring in. You end up losing. So, you know, in the past 4 houses I've done, I said, let's not bother. It's not worth it. You'll end up losing. You'll get a plaque for your wall, but what's that worth? I'll write you a plaque. Yes, Lloyd?
When you went through that initial stuff with the glazing, you had clear, and then you had double E and so forth.
Mm-hmm.
Is there not a single E that you can use, and how does that work into that?
Well, there's,
Could you repeat the question?
okay, the question was what different types of low E is available, and how do you make your choices? And again, you have to go to the window manufacturers. I've got a list over there from one of the window manufacturers that gives all the different low E films that they have and different characteristics. And you just have to go through that quick little energy balance to see what makes sense for you. And I remember when I got all excited about the low E 188, you couldn't get that in residential window units. If you bought big pieces and you wanted to buy 2,000 pieces, you can get it. But if you wanted it for regular windows, you couldn't get it. So we were recommending using clear over clear on your south wall, which was totally against the HERS. The HERS wanted you to use low E everywhere. And so the last time I did a HERS rating, I took a creativity special point for saying, no, I'm going to use clear over clear on my south wall.
Well, when I built a house in 1980, there was
No,
E.
right.
And I subsequently added one E, one low E, whatever, to some windows in the house, and you could stand in front of them and ascertain the comfort difference.
Okay, so you added a film to the inside
Yeah, you
of your existing glass?
You could
Yes.
stand next to this window and stand next to the other. Pretty empirical, but it worked.
Oh, that's a,
Tremendous difference, and so.
Yep,
In the
yep.
house that I built here, I only used one E, and I'm wondering whether that was the wisest choice, or what you would advise a customer to do.
Well, it depends on the characteristics and how much actual solar heat gain it cuts out. Now, when you stand next to the glass, you're comfortable because it's going to be 4 to 10 degrees warmer because of the emissivity characteristics of that glass. There are special guns like this that you can get to actually tell you your solar heat gain coefficient through that low E film. And so I would suggest moving in that direction. I'm not sure who has one. You know, I heard about them through NRAIL, but hopefully someone in the state might have one. And you can just, you know, shoot that glass and find out the characteristics. Any other questions? Ingrid, yes.
The latest buzz in residential housing, green residential housing now is passive house. I was wondering if you had any comments to make about that approach.
Okay, what are my comments about passive, I call it passive house, which is the new German standard that came out of Germany, where they see the sun 3 days a year, but they're very avid about energy conservation and a standard of adding so much insulation that you can heat the house with almost a candle, or you and your dog. To me, globally, it's a waste of resources for this area. We don't need that kind of standard here in New Mexico. If you took that insulation and divided it into 3, you keep a third and give it to 2 other families that can't afford insulation, and you do an energy balance on those 3 houses, you're going to be better off with distributing that insulation than you are with one house with this much insulation and 2 houses with no insulation. So I'm more for sharing the resources globally than, you know, over-insulating and over-tightening a house to where now you have to cut a hole in it, put a fan on it, put power to the fan just so you can breathe. You know, that to me makes no sense, where I think if you built the way we used to, where the house leaks and you get a little air and some fresh air, and put in 2 extra square feet of south glass to make up the energy difference. That's my approach.
Thanks.
Okay. Any other questions? Ms. Lloyd?
I'm still wrestling with mass versus no mass, because when I
Oh,
built
yeah.
my house in 2004, I did this whatever sheet CID gave me at
Mhm.
the time, and my house, which right now pretty much heats itself because I have
Right?
this kind of design, I barely pass their
Energy calcs?
requirement against 2004, which is nothing like it is
Mhm.
today.
Right.
And I could barely make that house pass. And yet I've got the mass, the house is comfortable, the house never overheats, it does, you know, you know how it
Sure. Mass is very important. And that's, I guess, part of Lloyd's question is how much mass, or how do you calculate mass into this? And
I'm sorry, but another question is, how
Okay.
do these programs deal with this?
well, the HERS rating, I'm not sure, but when I first did it, they had no mass. And it flipped me out, and I started screaming and yelling. And now I understand mass is part of the calculations, and it is very effective, when you put it in. And with a passive solar home, you definitely need that mass to absorb all that solar gain that you get the first 6 hours of a day in January, and then you need to let it ride for 18 hours. So you need to store it, and that's a big function of the area of mass, how much of that mass is seen directly by the sun, and the specific heat of the mass, which is usually around 0.2 to 0.23 in most masonry type materials, where water being 1. 5 times as good. Madeline. We're talking about using water walls in her new design. Yes?
So how do you balance that? In the wintertime, thermal mass is soaking up the heat, but it's also soaking up that heat for a lot longer period of the day during the summer. How do you dissipate that heat effectively?
Well, you don't really have to worry about it in the wintertime unless you're under mast. If you're under mast, the temperature of that house is going to climb rapidly. Okay, so you add more mass, more surface of mass, possibly water if necessary, but we usually get away with, a good third of our glazing and trom walls. And that puts that mass right where it needs to be. That heat moves through that wall at about 1 inch per hour, so you can time it to come into that house in the evening. And that heat starts radiating in the evening, so you're blocking a lot of that daily sun and storing it up for the evening. So you balance it out that way. But you need to run calculations, and not necessarily the calculations I used, and definitely don't use a HERS rating to design a passive solar home. You want to go to eQuest or DOE2 are the two real nice programs now. And then there's Energy 10, which Bristol and I have used very much, but that's kind of more for specifically saying, should we put the overhang out this far or this far, for just kind of little fine-tuning stuff. But for overall, eQuest and DOE2 are very, very good programs for designing a passive solar home. Steve, yes?
Mark designed a passive solar home for me in 1989 and had around a building in 1992. It's a wonderful, comfortable home with adobe walls and clear-story windows and palm walls. It's very comfortable, winter or summer. I'd like to say, however, that I did do a HERS rating on it. It comes in at around 70. There are things that we could have done to it, which would
Oh, yeah.
HERS rating down probably below 60.
Mm-hmm.
But I don't think that the HERS rating really is applicable to this house. HERS ratings I do on other frame and stucco houses may or may not work pretty well for them, but we're not measuring the house properly with HERS, the REMRIF program. So
Yeah.
it's a much better house than the HERS makes it.
I was designing more passive solar homes 20 years ago than I am now. And I blame all these silly codes that lean us out, and then all the government subsidies that they're giving to other systems, and people get excited about that. When you ask people, what's a solar home? It's those horrible things with the garage to the south and PV panels on the roof. And people are proud of them. Oh well. I think that ties up our presentation. I thank you all for coming, and it has been documented on video, and it will be on YouTube. So if you ever run across a building official or anybody that teaches sustainable design at the school here, tell them to look at it. I'd appreciate it. Thank you.